Hello everyone. Today we will be continuing our discussion of fair division games with the next of our fair division methods, known as the lone divider method. Now, the lone divider method is kind of related to the divider chooser method that we talked about in the last video, except basically we have extended the divider chooser method to fair division games where we have 3 or more players. Now, the basic premise of the lone divider method is that one player is going to be the divider. They're going to divide the assets into however many equal shares depending on the number of players. And then the other two are going to decide which of those shares are fair shares to them. So, to look at an example, this is kind of similar to the example we looked at in the last video. Say we have a cake that's in 3 parts, chocolate, vanilla, strawberry. And we've got 3 players. A likes all 3 flavors equally. B doesn't like strawberry and likes chocolate 3 times as much as vanilla. And then C only likes chocolate. Now, first off, we need to decide which player is going to be the divider and which ones are going to be the choosers. This is something that would typically be done at random. For the purposes of today, we'll say that A is our divider. So if A is the divider and A likes all 3 flavors equally, then one way that A could potentially divide this would be simply to just split this cake so that each section of each different flavor is a separate share. So we'll call the chocolate share 1, vanilla share 2, strawberry share 3. So now the next step is to decide which players, or which shares players B and C believe are fair shares to them. So one way that we can do this is we can just sort of figure out what percentage of the value of the whole cake each share is to each player. All right. So, for starters, player A values all 3 flavors equally. So, for player A, all 3 of these shares are going to be worth 33% or 1/3 of the cake. Now we get to player B. So, player B does not like strawberry, but likes chocolate 3 times as much as vanilla. So, since player B does not like strawberry, that share 3 is going to be worth nothing to player B. And that leaves us with 2 shares, share 1 chocolate, share 2 vanilla. Since player B likes chocolate 3 times as much as vanilla, that means basically that the value of these two are going to be 3 to 1. So in this case, this would be, chocolate would be 3/4 of the value of the whole cake, vanilla would be 1/4. So we would say that share 1 is worth 75% and share 2 is worth 25%. Note that in this case we have 3 players, therefore a fair share would be 33% or 1/3. So that means that for player A, any of these are fair shares. For player B, only share 1 is a fair share. Similarly, for player C, we know that player C only likes chocolate. That means the whole value of the cake is going to be the chocolate section, or share 1. Shares 2 and 3 are worth nothing. So we have a bit of a problem here. So for player player A, we can give them any of these 3 and it's not an issue. But for players B and C, only share 1 is a fair share. So we have now sort of a standoff for share 1, basically, between players B and C. So at this point, what we would do, let's say things were switched up a little bit and player C liked vanilla instead of chocolate. Now we would no longer have 2 players fighting over the same share. We could just say player A gets share 3, player C gets, with the strawberry, player C gets share 2 with the vanilla. Player B gets share 1 with the chocolate, everyone's happy. But since we have this sort of standoff, we have to find somewhat of a workaround for this. So the first thing that we'll do is we will give share 3, let's say, because this is the share that players B and C don't want at all. So we're going to give this to player A. So now that leaves us with this one larger chunk that's still undivided, or that's still not divided up between players yet, and this is shares 1 and 2. So what we're going to do basically is we're going to recombine shares 1 and 2. So this represents the parts that have not, of the assets that have not been given away yet. So we're not worried about share 3 anymore because we already decided that's going to go to player A. So now what we're going to do is basically players B and C are going to divide this using the divider chooser method. Now, let's say that player C is the divider. So C is our divider, and then B is our chooser. Player C only likes chocolate. So player C, if we ask them to divide this into 2 equal shares, is just going to do it in such a way that we're splitting the chocolate right down the middle. Player C does not care about this vanilla part. So we'll call this share 1 and this share 2. Now, player B likes both chocolate and vanilla, although chocolate 3 times as much as vanilla, but since these two have equal amounts of chocolate and this one has this big vanilla piece versus nothing over here, player B is going to prefer this part. So share 1 in this case will go to player B, and then player C is left with share 2. Note that basically in this case for player B, for player C, this share is worth 50% of the value of the whole cake because it's half of the chocolate share. So C gets a 50% share, so they're totally happy with that because that's more than 33%. And then B gets basically this 25% plus half of their 75%, so that would be 62.5%. So B is very happy with their share of this. So this is how we can use the lone divider method to sort of ensure a fair division happens when we have 3 or more players in a fair division game. Thank you for watching, and I'm of course happy to help with any questions.